Hello everyone, in this session I'll be explaining a very simple code in order to control GPIO output. What is GPIO? GPIO is nothing but general purpose input output. Each pin, as we have already discussed in previous session, can be designed to perform multiple tasks, and one of the tasks which a particular pin can perform is to act as a general purpose input output pin. Okay, so if a particular pin is acting as a general purpose input output pin, how exactly we can manipulate its data is what you will learn in this particular code. What exactly this particular code does is, first of all, it sets the pin 0 to 15 of port 0 as GPIO pins. After that, it sets the last 8 pins, that is 0 to 7th pin, as output pin. Okay, after that it sends a value high for some duration of time to these pins and then changes those values to low, and this continues as a loop. To make it more understandable, if these pins are connected to LED, then those LEDs will keep blinking for the duration of time specified in the code. Okay, so now let's just see what's happening here. See, there are some numbers specified here. These are actual addresses defined in LPC2148 for pin select, input output direction, input output set, clear, and input output pin value registers. But the names I have given here are defined by me. You can change it as per your convenience. EQU is an assembler directive which makes sure that these symbols are associated with these addresses. Next, we have again assembler directive area which defines specific section of memory to store this information. GPIO is the name I have given for this particular section of memory. Code informs these are just instructions, and read only informs that the instruction stored should not get modified during runtime. Entry indicates where exactly execution starts, that is at this particular spot, which is nothing but the very first label that you see after the assembler directive entry. Okay, so now let's just start with the code. The very first thing you will see is whatever is the address associated with pin select 0 is stored in register R0. Okay, after that I'm loading a value 0 to register R1, and then the value of all 0 is stored in the address associated with pin select 0. Why do you think this is done? If you remember checking about the pin select 0 register, every 2 bits of pin select will control one particular pin. And if you are discussing about pin select 0, see, even if this is just a name, it is associated with this particular address which is meant for pin select 0 register. Okay, which in turn controls port 0 pin number 0 to 15 by storing a value of pin select 0 as all zeros, that is starting from 0th to 31st bit. What we are actually doing is we are setting the first 16 pins of port 0 to provide GPIO functionality. Okay, that is the first thing we are doing here. The address associated with input output direction register is stored in register R0, and then I'm storing a value FF in this particular memory location. So what does this do? I know that my IO0DIR register will control port 0 pin number 0 to 31. So in this particular register, if I store value F is nothing but 1111 and followed by one more F, and all higher values are set as 0. Okay, until the 31st bit. What this will do is the last 8 pins, that is port 0 pin number 0 to port 0 pin number 7, these pins are set as output pins. Next thing that we notice here is the address of set register, that is input output set register, is stored in register R2, clear register is stored in R3, and my pin value register is stored in R5. So next I'm loading an actual value of FF in the register R4. So let's see what exactly happens here. This is a simple loop. In this loop, first thing I'm doing is, to my address associated with the input output set register, I'm storing the value FF. So what do you think will happen as soon as I do that? Here, let me consider this as my IO0 set register and this is my IO0 pin value register. As we have already learned in the previous session, this particular register is used if I want to send a value 1 to the output. Through this particular register, I can read the values of my GPIO pins. Okay, now let's see here. What R4 content is stored in the location pointed by register R2, which is nothing but the address associated with IO0 set register. So what is the value I'm trying to store? 1111 1111. What does this mean? To all the pins starting from pin 0 to pin 7, send the value 1. What happens to the remaining pins? They will retain their previous value, because of which it doesn't matter what values are stored here. Okay, in the initial, that is the 0 to 7th pin, will get the value 1. Okay, that is what we are trying to do. And as soon as the next instruction is executed, that is this LDR instruction is executed, R6 will show this particular output. Then we are calling delay using a branch with link instruction. We have already learnt about this, and what we have understood there is, when this instruction is executed, whatever subroutine is called, the control jumps there, finishes it and jumps back to this particular instruction, because before this particular jump happens, link register is updated with this particular address. We will see what exactly is there in that particular subroutine. Okay, you can see the subroutine here, delay, and what is written is R7 is loaded with a very small value 2. Okay, if you want to increase the time duration, then increase the value here. Okay, and we have a loop here. This loop just does one task, that is subtract R7, then branch back if R7 is not equal to 0. Once when it reaches the value 0, you will jump to this step which performs branch and exchange. Okay, what is branch and exchange? It will jump back to this particular instruction. Now in this case both are ARM code, so there is no problem. If the last bit of link register was set as 1, in that particular case it would assume that the jump should happen to a thumb code. Okay, so here there is no such problem, it will just jump back here and continue execution. Okay, so this is used just to increase the delay between high and low output. Okay, so next what we notice is we are storing the same value. What is the value? FF value into the address associated with register R3. R3 is associated with the address of input output clear register. Okay, so what will happen if here we write a value FF to the register input output clear? Immediately at whichever position I have written 1, that specific pins will now hold a value 0. Whichever pin positions are filled with the value 0, it will remain unaffected. So after storing this value, I am trying to read my GPIO output again and store it in register R6, and then again I am calling a delay, followed by that I am looping back here continuously. The last 8 GPIO pins will keep changing from high to low and then again high and low, and this continues as an infinite loop because I've written branch to loop without any condition. Okay, and here this particular end just shows the end of the source file. Okay, now let's see all these things happening. So for that, first thing we'll do is we'll check if there are any errors. There are no errors, so we'll go ahead with debugging. Okay, so here I'll go to my peripheral. There I'll open GPIO slow interface port 0 because the addresses I'm working with are associated with port 0. Okay, as you can see here. Let's see what happens when we run this code. So through these instructions, I'm making sure my pin 0 to 15 set as GPIO pins. Okay, this particular instruction will make sure these pins are set as output pins. Okay, you can see that the same value is noticed here. Okay, now I will associate my concerned registers R2, R3, R5 with respective memory mapped IO register address. I'm loading my desired value into register R4. The first step which is executed here is I'm storing R4 content into the location or memory address pointed by R2, because of which IO0SET gets updated. Okay, if you notice, as soon as IO0SET is updated, all the output pins will have that specific bit positions as high. Next, I'm branching to a loop. This is used just to create a delay. Once the delay is completed, we are storing the same value FF to IO0CLR register, which will make sure that all output bit positions which were initially high are now low. Okay, now you can see output changing to 0, and then this instruction, as it did in this particular case, we use it to check what exact value is stored in the IO0 pin register. So you can see that the value 82 all Fs and 00 is stored there. Okay, we actually don't need this particular instruction since we are seeing the simulation happening here. Okay, if this was not there, then we had to check the value through this. Okay, and now we are again branching to delay. Okay, fine, and we are returning back to the loop, and this will continue. Now if you want to see this happening continuously, let me run it using this. So if you see here, continuously for some duration of time the output here is set, and for some other duration of time it becomes off. If you want to keep it on or off for a longer duration of time, you will have to change the delay, but you can clearly see the blinking happening here or the output changing here. The pins here show the output which appears at the actual pins, while IO0 pin will show what value is seen by the CPU. Okay,